Okay, another type of problem you might have then. We could say, okay, what's the equation of a circle of radius 3? About centered at the origin. Let's be sure we get that. Okay, now you might have to review a little bit of chapter 1, but there's a very simple way to write down that curve, and we could have any center. Okay, but center of the origin, there it is. Okay? Straight line, slope of 4/3, y-intercept negative 1/3. Well, if this is the equation of the line, this is what the line is. We can even sketch the situation. I should have drawn the circle first, but that's not too bad. The circle has radius 3, slope is 4/3, so the line might look like this. We see that the circle is clearly intersected twice by the line. So we want to know the coordinates of these points. Well, the situation is no different than before. Okay, we solve one of the equations for x or y and plug that solution into the other equation. So I'm not going to write out the details of the solution. We just add 3y to both sides, divide by 4. I chose to solve for x because the signs end up easier, but we could as easily have solved for y. Plug into equation 1. Don't know why I have parentheses around that, but I have them. Okay, and you get this quantity squared, that's your x squared plus y squared. Squaring the numerator, we get 9y squared plus 6y plus 1. Squaring the denominator, we get 16. We multiply both sides by 16. And 16 times 9 is 144. So now we have 25y squared plus 6y minus 143 equals 0. Well, 143 is not something we want to try to factor, it's prime. So, actually it's not prime. It's 11 times 13. But that's not going to help us any. So we just go to the quadratic formula. It's not negative 25, it's negative 6. Okay, then plus or minus the square root of 6 squared, which is 36, minus 4ac, which is going to be a pretty big number, except 4a is 100, and that's convenient. So we get 14,300. All that over 2a, a being 25, that's all over 50. Now the square root of 14,400 would be 120. That's a little less than 120. I'm going to say this is approximately equal to negative 3/5. Okay, let's see. 14 squared, 13 squared would be, 11 squared would be 123, so that would be like 50. Oh, come on now. 120 be like 115. That would be 115. It'd be 119 and a half. Okay. 119 and a half divided by 50. Well,
question. Observation.
Huh? I'm sorry?
Observation. Didn't we lose b squared under that root? Square root?
Oh yeah, but yeah, you're right. So it'd be this with 36. But that doesn't make a lot of difference. So I just kind of neglected it. And that might actually get us up to 119.6 here. Okay. But I did neglect that. Okay. And then dividing that, that's about negative 0.6 plus or minus 2.39. That doesn't seem to work real well. That would give us like a negative 2.99. Could be that my estimate here isn't very good. Oh, wait a minute, that's negative 6 over 50. Not negative 6 over 5, so that's negative 0.06. Still not very good. Still has the zero weight to the left. Slope of 4/3. Even if the slope was 1, you would be at like negative 2.1 and positive close to 2.1. Something there seems a little bit amiss. But this could equal then negative 2.5, 2.45, or 2.33. If the slope was three-fourths, that would make a little more sense. With a slope of 4/3, it doesn't. Okay, so this isn't totally implausible. Remember that for a circle of radius 3, we have negative 3 here and plus 3 here. So both of these are in the range of points that could intersect the circle. What I'm saying is Pretty simple problem. I shouldn't have done this to us or to me. But again, I'm not seeing where the error might be. I'm pretty sure that I'm close with this square root. I'm pretty sure that 4 times 25 is 100, and if you multiply that by 143, you get 14,300, and then add 6 squared. I think that's right. So I'm not sure where we're going to miss, but with the slope as it is, that number's too far to the left, that number's too far to the right. These estimates would give us points like here and here, not points like here and here, where your 45-degree line, well, I can't even draw the thing, but this is above the 45-degree line. The 45-degree line intersects here at about 2.1 and negative 2.1. So, something is a little strange there, but should be easy to correct. And there's no need to worry about it because the process is correct. Okay? Now the point is that these equations up here give you curves. So on the earlier equations that we looked at, okay, well, the equations involving x, y are beyond the scope of first semester calculus. You learn to do that when you do rotations in second semester calculus, but unfortunately people are typically not even doing that anymore in second semester calculus. If you take this, what's this equation describe? Well, y equals what? 1/3 x squared plus 8/3, right? That's just your x squared graph, squash it down by a factor of 3 and then raise it up 8 units. In other words, this is just a parabola and this is just a straight line that intersects the parabola. Okay, so I just buried my white chalk. If you want to do a graph of this, it's a pretty well squashed down parabola, and the equation is y equals 4 minus x. So up here is 8/3, which is just short of 3. Up here is the line y equals 4 minus x. It intersects, actually, a little bit strange because if I graph these two equations, I find that there are solutions because this line has a negative slope and a y-intercept above the vertex of this parabola. Well, a straight line with negative slope above the vertex of an upward curving parabola should have 2 points of intersection. But we found that there are no points of intersection because we got imaginary, well, complex number solutions. Which means that something isn't consistent. Either my graph isn't right or my solution isn't right. That's an interesting conundrum. We're not going to spend a lot of time worrying about it, but understand that if this is interpreted in terms of the two curves or two graphs, my solution tells me something. Well, it tells me that there is no real valued x where this thing intersects, but my graph tells me, oh, wait a minute. A little embarrassing, but not really, because I'm used to being embarrassed. This would be y equals negative x squared over 3. So when I said you squash the thing down and then raise it up, no, you squash it down, reflect it through the axis, then raise it up. So that I thought there was a problem, but there isn't, because there's your parabola and your straight line just misses it. Okay? So if I graph this equation and this equation, the two graphs don't intersect. The parabola is below the straight line. Okay.